Hi, this video is an update of my earlier post for making Alexa enabled smart relay switch for converting your existing legacy home appliances to a smart home appliances. You can assemble this unit into a 8x4 switchboard like this. Once you complete this project, you can enable or disable, switch on or switch off the devices by using Alexa. Switch on living fan.
Okay.
Alexa, switch on living light.
A few things share the name living light. Which one did you want?
Living light.
Okay.
Alexa, switch off living fan.
Okay.
Alexa, switch off living light.
Okay.
In my earlier project, I used Generic API for integrating with Alexa. Also, I used this ESP8266 Wi-Fi module for configuring Wi-Fi. So now this Generic, they stopped that free service, and now it's moved to Generic Pro, and it is supporting only 4 devices. So if you want to support more than 4, then we have to go for a subscription. So then we have to pay. So now I moved that the integration to another library. So similarly, this Wi-Fi libraries, we have to hard code the Wi-Fi username password. So the problem of this one, actually, each time if you want to change that Wi-Fi, then we have to change the code and upload to the ESP. So now I am in this project, I am using Wi-Fi manager. So in that case, we don't have to hard code the Wi-Fi details. So then when we are switching on, it will try to log into the saved Wi-Fi. So if it is not able to latch to any Wi-Fi, it will give you a configuration GUI. In that we can configure our Wi-Fi and it will connect. This is the new Wi-Fi manager library, and here this is the ESP Alexa library. So you can add these two library, which it is by default available with this Arduino IDE. So in that tools, if you go to library manager, you can add these two in the search. So after that, there is no much changes in the code. Then in the hardware side, in this project, I am using ESP8266 12E/F or S, that board. Actually, it is not a development board because it will be having only the chip. So there will not be any additional components. So I will explain that how to solder this one into a common board and how we can program it. For programming ESP8266 12E board, first we need a 12E this chip. Then we need 4 10K resistors, then 2 push buttons and 1 common PCB 0 board, and there should be a USB to serial adapter like this. First, we have to solder these legs to this ESP8266 12E board. So first we have to plug that board into a stand. Then we can take this old the leads, which is that any component lead, resistor or capacitor which we used earlier, that the cut and removed legs. So then we can just fold it like this, and then we can put it into that each of the holes, and we don't have to solder any legs in the front side, so we have to solder in both the sides. Once all these legs are soldered, then we can arrange the space in of those each legs like this. So then we can easily insert into that common PCB. So once it is arranged the spaces, so then we can cut the legs into a same length. We can take a small this zero board, and we need only a small portion of this board. So then we can insert that chip like this into the board. This is the circuit diagram. So we have to connect all these four 10K resistors like this. Then two switches. One switch it will connect to the GPIO 0 pin, and another switch is to the reset pin. So now I have installed all these four 10K resistors. Then here I put these jumpers for connecting the TX RX from the USB to serial converter, and these two switches here, and connected one resistor and one LED to see the power status. This is the track side of this PCB. So then we can make that track with that component legs itself. And here I used one ASM117 IC. This is for converting that 5 volt into 3.7 volt, which it is needed for the ESP chip. So I will show you the pin diagram of this ASM1117 chip. So this is the chip pinout. It is having total 3 pins. The first pin is the ground, common one, and the second pin is the output, and the third pin is the input. So we have to connect the 5 voltage to the input pin, and that 3.7 voltage, that is the VCC, to the ESP pin from the central pin. Once that board is ready, then we can connect to the laptop by using a USB to a serial converter, and we can load the sketch into the ESP chip. So we can connect the 5 voltage from that ESP board itself to the input of the ASM117 regulator, and the remaining TX, it should go to the RX of the adapter, and RX should go to the TX of the USB to serial adapter. So then once this is connected, then our IDE will be able to detect this COM port, and from there we can choose that upload option, so that uploaded sketch will be transferred to the ESP chip. So I have uploaded this sketch into the GitHub. So I will be sharing that link in this description. So you can go to that GitHub and download that sketch, and you can make the changes if it is needed, and then you can load to the ESP chip. Now we can take a 10 strip ribbon cable, and then you can solder those cables to the board as per that pin out of our ESP chip, and then we can solder that plus 5 volt and ground also, and take that two wires also to the relay board, and then relay board side it is a socket, so that we can plug into the relay board. We need one 5 volt SMPS board, so that you can get it from old mobile charger, or it is directly available in Amazon. So then this is that 5 volt SMPS board, which it is connecting to the ESP board which we have assembled, and from there the ribbon cable it is connecting to the relay board. So now the setup is ready. So then we can power on this one, and after that, after powering on, it will give you a GUI for configuring the Wi-Fi. So I will power on now, and then I'll show you the GUI. First go to that Wi-Fi. So here if you go, then it should list our SS Alexa switch. Yeah, here we can see that Wi-Fi. So I am not given any password, so then we should be able to directly connect now. So after the connection is successful, it will automatically redirect us to a web page, which it is a configuration page. So the default IP of this one is 192.168. 0.4. Yeah, sorry, 198.168.4.1. So this is the default IP, but we don't have to remember that, automatically it will get forwarded. So in this we can go with the configure Wi-Fi. So then it will list all the available Wi-Fi to us. Yeah, so then from that we can choose the one which we needed and we can configure the password. So it will save this information to the ESP chip. So then next time when it is switching on in this network coverage, it will be automatically taking these credentials and it will be logging in. Just give save. So once this saving it is over, and if it is able to connect to the Wi-Fi network as a station mode, then automatically this access point which it was listed, it will be get disabled. See, then if you see now, we will not be able to see that this switch. So if you try, see it is listing, but if you try to connect, it will say cannot connect. So this is the way dynamically we can configure the Wi-Fi SSD to the this our smart switch. Once you connect the power supply, this is that 5 volt SMPS, then connect to the board which it is we assembled into a common board, and then connect that ribbon cable to the relay board. Then you can assemble all this into a 8x4 switchboard. So you can place the relay board here, then you can use glue gun, glue this one to fix it. So once you stick all this board to this box, then see, I have made holes here for routing the cables from the appliances. So once everything is assembled like this, then you can put the, you can use one switch here to switch on and switch off this unit, then you can wire it. Now I have assembled all these boards inside this 8x4 box. See, I have applied all this glue, hot glue I have applied. So now all are fixed, the power supply, then relay board and our ESP chip. So I have connected the 230 volt power to here, and it is connected by a switch and it is switched on. So now you can see that the built-in LED in the pin 2, it is blinking. That means it is connected to the Wi-Fi. So if it is the Wi-Fi connection was not success, then it will be permanently glowing, and the green it will show the power LED. So now we can tell the Alexa to find my devices. Alexa, find my devices.
Starting discovery. This will take a few moments. Turn on your new devices now, and if needed, put them in pairing mode. I found and connected 8 new devices including lights. Try saying, turn off guest light.
Alexa, turn on guest light.
Okay.
Alexa, turn on guest fan.
Okay.
Alexa, turn on living light.
Okay.
Yeah, so like this we can control all the 8 devices. So now we have to wire this one to our appliances cables actually. So we have to route all the cables here from the appliances switch. So then we are ready to go. So thank you for watching.